This is Jules Maxwell, Electromechanical Process Specialist with ARC Labs under ORG. Today's entry covers the VOLT system. Versatile OmniLink Technology is a modular component library built for rapid production, precise alignment, and creative adaptability. From joints to brackets and pivoting assemblies, every part is engineered to function seamlessly across a wide range of Dominion applications. The ARC Labs have been working on VOLT designs for quite a while now, and PCBWay has been supporting this endeavor. Although we usually collaborate with specialized parts, they have also been helpful in limited production runs of dozens of VOLT materials. PCBWay offers advanced 3D printing, PCB prototyping, and manufacturing services, making it easy to create custom and intricate components. Their expert support ensures ideas can be brought to life effectively and work for whatever the project may be. Today's assembly is an extreme case, a deliberate overuse of VOLT components to stress test the system's modularity and adaptability. Note, this project has been pre-approved by the Ministry of Omnitech Resources. This is not intended as a model for standard practice. VOLT was never meant to replace the Dominion's recycling and reuse protocols. It's meant to complement them. Constructing an entire mech from VOLT alone is feasible, yes, but doing so demands a significant amount of new material, which stands in contrast to the Dominion's reuse and adapt regulations. This testbed is the exception, not the standard. Future iterations will integrate more reclaimed scrap as originally intended. For now, where possible, Testbed 1 will still draw from the Omni Waste Reclamation District. Now, granted, the mech itself isn't the focus of this research, but it's hardly going to waste. Once assembly is complete, it'll be deployed to the front lines of the expanse with the Dominion Vanguard. And I'll admit, there's something thrilling about that. Real combat conditions, live fire stress, environmental wear, it's the kind of data you simply can't simulate in a lab. Watching VOLT components hold out on their own, that's where the system proves its worth, or doesn't. Either way, I can't wait to find out. In the meantime, let's talk about how Testbed 1 came together. As mentioned, VOLT components cover a wide range of systems and structural needs. There are enough panels and armor plates to build a fully functional cockpit from scratch if you wanted to. But in this case, we already had a surplus industrial enclosure with walls thick enough to take a beating, so we used that as the base. From there, VOLT components were simply welded on where needed. That's the beauty of it. Open-ended geometry, straightforward integration. I'll admit, reusing scrap isn't always easy, but that's not a shortcoming of VOLT. The system gives us potential. It's up to us, as designers, to make the most of it. VOLT doesn't currently include weapon systems. It's focused on universal components, not offense. That said, I think integration is feasible, so I'm noting it for potential future development. Before diving into Testbed 1 proper, we ran a few preliminary tests, basic stuff, just to confirm that components would actually fit together. That gave us two, well, let's call them structurally optimistic legs and one complete skeletal frame. None of them are field-ready by any stretch, but they did serve their purpose. Maximizing potential isn't about getting it right the first time, it's about pushing until something clicks. One variant tested mechanical pinning as a connection method. It technically worked, but it wasn't as efficient or as clean as simply welding the pieces directly, so that approach has been shelved for now. I think we're on version 12 at this point, but honestly, they've started to blur together. I've tried to stick with variations that share the same outer dimensions to keep everything modular, but some of the through holes are widely off tolerance. Unfortunately, we can't just fabricate endless versions of VOLT components to test every theory. The Ministry of Omnitech Resources has already informed us that we've exceeded our allocation for this test bed. Again. So we did what any engineer would do, salvaged what we could from the earlier trials. Still, that's the process, isn't it? Not perfection, but progress, and we're getting closer. It's worth noting for anyone working with the Volt system, don't feel confined to how the parts are shaped or where they naturally align. These components are meant to be modified. Cut them, grind them, weld them, whatever your build demands. That's part of what makes Volt so exciting. You can use the parts straight out of the system and get great results. Or you can push further and tailor every detail. There's no structural penalty for adapting them, only more potential to unlock. As you can see from testing so far, the upper body relies heavily on plates and hardpoint connectors, while the lower body makes extensive use of linkages and piston assemblies. The division wasn't planned, it just worked out naturally. There are multiple ways to reach a functional outcome, which is exactly what we want. Flexibility in construction for anyone using Volts in the future. Speaking of which, we do hope to release our blueprints publicly. That's the goal. But there's still quite a bit of data to gather and geometry to refine. Honestly, I'd estimate at least one more full test bed before we can begin rolling out a formal release. Additional funding would certainly help expedite the process. Unfortunately, yes, the approval pipeline is still a thing. Would it be faster without 5 layers of review? Absolutely. Would it exist without those 5 layers? Not a chance. So here we are, grateful, frustrated, and making progress anyways. Small support structures added around the primary autocannons serve as bracing for armor plating. As I've mentioned before, the Volt system isn't purpose-built for any one implementation, weaponry included, but its generic modularity makes it quite useful for supporting armament design. After sealing up the gaps around the cockpit using strips of reclaimed ties, we worked on the secondary cannons. We've also taken the liberty of showing how certain components, like the piston tubes, can be repurposed in weapons design. They work well as upper receiver housings or shrouds, but I would strongly caution against using them as direct barrel replacements. The interior is unrifled, and the tolerances are nowhere near what's needed for standard Dominion munitions. Adaptation is encouraged, but within reason. As demonstrated here, combining standard hardware with Volt's hardpoint connectors makes it remarkably straightforward to attach or detach components of any size. Speaking personally, I've found the geometric plates, simple shapes really, surprisingly effective for rapid design iteration. There were moments, like trying to mount the engine and cooling system to the rear torso, where it felt like nothing would quite line up. But then, 2 basic parallelogram plates solved it all. Suddenly, everything just snapped into place. Sometimes it's the simplest shapes that unlock the most elegant solutions. We had to make a few modifications to slot in a reclaimed intake unit for the engine, but honestly, everything else fit together better than expected. 2 small vents were added to the sides of the parallelograms we installed earlier. Nothing complex, just practical. The rest of the upper body followed standard Dominion assembly guidelines. And actually, that gives me an idea. There's definitely room in the Volt ecosystem for simple utility modules. Things like standardized fan and vent components that could support power and thermal regulation across all sorts of systems in the Omniplex. I'll go ahead and add that to the list. The Volt system has given the Mech's legs an impressive range of motion. Smooth, responsive, and mechanically sound. So, from here, it's just a matter of attaching protective armor and final systems, like hydraulic pumps and sensor arrays, without compromising articulation. That balance between protection and performance, we're used to threading that needle. Aside from a few remaining pistons and minor additions, Testbed 1 is largely complete from a Volt standpoint. The rest is standard Mech construction, getting it fully combat capable and ticking all the usual boxes. That part's familiar territory for us at ARC Labs. We handle experimental systems and conventional builds in equal measure. While building Mechs is quite literally our job as a subdivision of the Omnitech Research Group, I'll admit I'm genuinely pleased with how this one has come together. There are still a few lingering details like pinholes that need filling. More overhead than I'd prefer for a test unit, but such is the nature of research. Testbed 1 has taught us a great deal, and I'll need to spend some time reviewing the notes and observations we've collected. With any luck, the data from this iteration will be compelling enough to justify a larger allocation of new vault components for the next phase of development. Throughout assembly, we noticed several cases where a plug or cover plate would be useful for exposed through holes, something we'll need to solution properly going forward. Interestingly, that observation led to a bit of an epiphany. We could make the hardpoints themselves modular. Instead of a single-piece unit, we shift it to a two-part design. And while that introduces a slight increase in part count, the payoff is absolutely worth it. These new modular hardpoints can now function not just as mounting anchors, but also as washers, bushings, protective covers, and more. It's a surprising amount of utility from such a small adjustment. Normally, we push the vault system toward simplification and part reduction, but in this case, I think we've genuinely struck gold. The original hardpoints were directional. Now, each segment is orientation agnostic, which is exactly what you want in a truly flexible modular system. We didn't showcase washers on Testbed 1, but with the split hardpoints, we've already got a perfect foundation for future variants. What I'm calling the waist of the mech wasn't part of the original plan. If you'd been paying attention, you might have noticed in earlier footage that the pelvis was mounted directly to the cockpit. That worked fine, but we wanted to demonstrate how easily suspension or structural complexity could be added. Honestly, even with all the pistons on the legs, I felt the upper body could use a bit more mechanical flair. Adding a waist was incredibly straightforward. The torso already had a hardpoint, and the pelvis had a through hole ready to go. It was no different than stacking a few washers or dropping in a spacer. We just swapped in a longer threaded rod and bolted it together. I won't walk through every hypothetical, but it's worth noting. This kind of modular expansion works anywhere on the frame. If we wanted to give the autocannons proper articulated arms, with elbows, wrists, you name it, we could. All it takes is more vault components and a few bolts. That's the system working as intended. Something I've only just realized, although it's painfully obvious in hindsight, is that any mech using the standardized volt connections could potentially hot swap components in the field. Not seamlessly, of course, but imagine this. A mech takes damage on the front lines, loses its primary weapon, and scavenges a replacement from a downed unit. If both are built on the volt system, that swap becomes entirely feasible. And it's not limited to combat. Construction, logistics, repair crews, any sector could benefit. Field repairs done ad hoc. The implications aren't just exciting from a design perspective. They're thrilling when you think about system-wide deployment across the Omniplex. Now, not every component on Testbed 1 is part of the vault system. The communications array mounted on the rear torso, for example, isn't exactly modular. But that actually strengthens the case for a broader standard. If specialized components, like sensors or comms units, were mounted into Volt-compatible plates, then even if the hardware itself isn't design agnostic, the mounting system would be. That means easier swaps, faster repairs, and much greater long-term adaptability across machines. These autocannons are definitely a specialized build, but they're mounted using a standard Volt hardpoint. As long as the ammunition remains standardized, there's no reason this couldn't be transferred to another mech down the line, at least from what I can see at this stage. We've mounted a reclaimed targeting system to the front, which marks the final major technical component for this build. All that remains is capping the hydraulic pistons. Since volt pistons are designed as generalized components, users should consider adding any specialized features their application requires. Things like bleed valves, additional hydraulic line connectors, or pressure monitoring ports. In our case, I have the team ensure that each piston could be serviced through its own access cap, which keeps things simple without compromising maintainability. Since Testbed 1 is slated for live combat deployment, we went with custom shielded cables for the primary electrical connections. It takes a bit of extra manual effort to get them right, but in my expert opinion, it's absolutely worth it. If a cable takes a direct hit from shrapnel or a projectile, you still want power flowing where it needs to go. Most systems draw power directly from the volt components themselves, since they're built for both structural support and plug-and-play electrical integration. External cabling is only needed for high load transfers. Specifically, routing power from the mech's engine into the broader electrical systems. Everything else runs cleanly through the frame. Mass-producing volt components sounds like a dream, and I mean that sincerely. Imagine a future where every mech, every machine in the Omniplex speaks the same mechanical language. Any joint, any plate, any connection point would be interchangeable, repairable, and swappable on the fly. But that future still feels distant. Right now, every volt part is made in limited runs. Small teams, outdated machines, and tolerances that shift from batch to batch. It works, but just barely. The problem isn't with the system, but with the world that we're building it in. Before the awakening, everything ran on true artificial intelligence. Factories, farms, infrastructure, all fully autonomous and fully integrated. And when Neo City Zero fell silent, when the collective rose, when the war started, it all collapsed. The Dominion didn't just ban AI. We lost the foundation that let us build at scale. Nowadays, even simple automation is a risk. Wireless signals are vulnerable. Anything that transmits can be hijacked unless it's incredibly simple. What little remains of old-world manufacturing is broken, buried, or scavenged. That's why we hand build. That's why every mech is different. And that's why something like Volt, which could finally bring standardization back to the Omniplex, feels so difficult to push forward. Every time I request another fabrication cycle, I'm told the same thing. You've hit your quota. I was still thinking about that when he appeared. No sound, no warning. Just a man standing at the edge of the lab, wearing a Dominion insignia on a uniform I didn't recognize. It looked official, but unlike anything I've seen in any department. He said only one thing: clones fall in swarms. I blinked, unsure what to make of it, but the words stuck with me. The collective thrives on uniformity. Every unit is, for the most part, identical. Every flaw is repeated. One successful intrusion can ripple across the entire swarm, but for us, our chaos is our strength. Every mech we build is a new equation that they have to solve. I turned to ask what exactly he meant, but he was already gone. Maybe Volt isn't about making everything the same. That would make us vulnerable. But maybe it's about giving us the freedom to stay different more effectively, if that makes sense. The dream doesn't need to vanish, it adapts, and that might be enough. It's a comforting thought, the idea that our diversity keeps us safe. But that's not enough to stop impact damage, so we need to continue with testing. Full system testing isn't just about function, it's about interaction. how every moving part tolerates stress, shares load, and behaves under strain. One perfect joint means nothing if the surrounding structure fails the moment it's put under pressure. Here are some of the tests that we ran. The primary autocannons were tested for recoil control and sustained fire stability. Secondary artillery units underwent shock absorption and reload cycle timing evaluations. The calves were stress tested for piston articulation and load-bearing under dynamic motion. Feet were assessed for ground compliance, traction, and balance during movement shifts. The pelvis assembly was tested for rotational strength and lateral torsion resistance. Thigh components were evaluated for lift capacity, suspension movement, and pivot alignment. The torso was tested for recoil dampening and internal systems isolation during fire. With the system verified as fully functional, we moved on to final steps. These included applying official Dominion insignia, advisory labels, and operational markings across key subassemblies to ensure safety, clarity, and proper field servicing once the unit is deployed. Arc Labs markings were applied to the leg, with danger labels added to each weapon and a rear warning on the pelvis engine. We also placed caution panels near the knee joints due to their heavy exposed movement. Identification sigils were placed on various sensors and systems to complete final regulation markings and satisfy Dominion compliance protocols. Before deploying Testbed 1, we applied a mineral suspension wash across the entire frame. It's a standard treatment for sealing microfractures, revealing low-tolerance seams, and reducing surface glare during calibration. The darkened surface layer also protects against ultraviolet degradation from prolonged exposure in the expanse, and abrasive particulate impact during field movement. It's not pretty, but neither is the work that this unit is being prepped for. A bit of grime on the surface helps keep attention where it matters, on performance, not polish. If it's clean after deployment, we didn't test hard enough. Besides, residue tracking also aids in detecting heat leaks and joint stress over time. The VOLT system, or Versatile OmniLink Technology, presents a practical step forward in modular mech construction. It was built for compatibility, adaptability, and ease of fabrication using repeatable component designs. Throughout development, VOLT parts demonstrated reliable structural alignment, strong articulation, and seamless integration with both reclaimed scrap and newly fabricated material. This system is not meant to replace traditional methods, but to support and enhance them. It provides a shared foundation without restricting design freedom. Whether used in combat or construction, VOLT offers real, measurable potential. What comes next depends on how we choose to apply it. A new InfoSphere analyst has been promoted. Thank you.